When considering submetering options for a 4-unit apartment building converted to condominiums with a detached garage on the house meter, several approaches can be taken to fairly allocate electricity costs among the owners. Firstly, individual electric meters can be installed for each unit. This method provides the most accurate and reliable measurement of electricity consumption, but can be the most expensive due to the need for significant rewiring and the purchase of multiple meters. Secondly, submetering panels can be used. These panels measure the electricity consumption of each unit and transmit the data to a central location, facilitating billing. This option is generally less expensive than installing individual meters for each condo unit, but may not provide as detailed data as individual meters. Thirdly, smart plugs with energy monitoring capabilities offer a more accessible solution. These plugs can be installed in each unit to track the energy consumption of individual appliances and devices. The data can then be monitored remotely through an app or website, giving each owner insight into their energy usage. Beyond direct measurement, alternative solutions can also be considered. Time-of-day pricing involves implementing a pricing structure that varies depending on the time of day, with higher rates during peak usage times. This encourages tenants to avoid using the garage during these peak hours. A flat rate charge, involving a fixed monthly or annual fee for garage electricity based on an estimate of average usage, is another option. While simple to implement, this may not be equitable if some tenants use the garage more than others. A parking meter system could be installed in the garage, requiring tenants to pay for the time they use it. This ensures that tenants only pay for what they use, but can be inconvenient and require maintenance. Other considerations also come into play when selecting the most suitable solution. The upfront and ongoing costs of installation and maintenance for each option should be considered. The convenience for tenants is also a crucial factor. Opting for solutions that are easy for tenants to use and minimize disruption to their daily routines will contribute to a more positive experience. Fairness is paramount, and the chosen method should fairly allocate costs among tenants based on their actual usage, rather than creating unnecessary disputes. When assessing electrical installations, the National Electrical Code, or NEC, provides guidelines to ensure safety and compliance. Article 220 of the NEC deals with branch circuit, feeder, and service calculations, which are essential for determining the appropriate size and capacity of electrical systems. For dwelling units, NEC Section 220.12 specifies a general lighting load of 3 volt-amps per square foot. This value is used to estimate the total lighting load for a residence, which is then factored into the overall load calculation. When calculating the total load for a dwelling unit, the NEC allows for demand factors to be applied, as outlined in NEC Table 220.42. Demand factors recognize that not all electrical loads in the building will be operating at their maximum capacity simultaneously. These factors reduce the calculated load to a more realistic value, preventing oversizing of electrical equipment. For example, NEC Table 220.42 provides demand factors for general lighting loads in dwelling units based on the total square footage of the dwelling. The first 3000 volt-amps can be taken at 100% demand factor. The next 120,000 volt-amps can be taken at 35% demand factor. And anything over 120,000 volt-amps can be taken at 25% demand factor. This means that only a fraction of the total lighting load is considered when determining the service size. NEC Section 220.53 addresses the calculation of receptacle loads in dwelling units. Receptacles are typically rated at 180 volt-amps per outlet, but the NEC allows for a demand factor to be applied to the total receptacle load. This factor recognizes that not all receptacles will be in use simultaneously. For example, NEC Section 220.40 now specifies that each receptacle outlet is to be calculated at not less than 180 volt-amps per outlet. However, NEC Section 220.53 permits a demand factor of 75% for the portion of the receptacle load exceeding 10 volt-amps. This means that only a percentage of the receptacle load is considered when determining the service size. NEC Article 230 covers service entrances, which are the conductors and equipment used to bring electricity from the utility company to a building. The NEC specifies the minimum size and type of service entrance conductors based on the calculated load of the building. It also provides requirements for the overcurrent protection of service entrance conductors, such as fuses or circuit breakers. These devices are designed to protect the conductors from overload and short-circuit conditions. The NEC mandates that all electrical work must be performed in a neat and workmanlike manner, as stated in NEC Section 110.12. This means that all wiring must be properly installed, supported, and protected. Electrical panels must be clearly labeled to identify the circuits they serve. These requirements ensure that electrical installations are safe, reliable, and easy to maintain. In addition to the general requirements for electrical installations, the NEC also provides specific requirements for dwelling units. These requirements are designed to protect the occupants of dwellings from electrical hazards. For example, NEC Section 210.8 requires ground fault circuit interrupter, or GFCI, protection for receptacles in bathrooms, kitchens, and other damp locations. GFCIs are designed to detect small ground faults and quickly de-energize the circuit, preventing electric shock. NEC Section 210.12 requires arc fault circuit interrupter, or SI, protection for circuits that serve bedrooms and other areas where arcing faults are likely to occur. SIs are designed to detect arcing faults and de-energize the circuit, preventing electrical fires. When selecting a submetering option, it is crucial to consider the electrical codes and standards that apply to the installation. The NEC provides comprehensive guidelines for ensuring the safety and reliability of electrical systems, and compliance with these codes is essential for protecting tenants and preventing electrical hazards. Furthermore, consulting with a qualified electrician or electrical engineer is recommended to ensure that the submetering system is properly designed and installed in accordance with the NEC and other applicable codes. Regarding the various submetering options, each has its own set of advantages and disadvantages. Individual electric meters provide the most accurate measurement of energy consumption, allowing for precise billing based on actual usage. However, the cost of installing individual meters for each unit can be substantial, particularly in existing buildings where significant rewiring may be required. Submetering panels offer a more cost-effective alternative to individual meters. These panels measure the total energy consumption of a group of units and then allocate the cost to each unit based on a predetermined formula. While this method is less accurate than individual meters, it can still provide a reasonable approximation of energy usage. Smart plugs with energy monitoring capabilities offer a flexible and affordable solution for tracking energy consumption. These plugs can be easily installed in each unit and provide real-time data on the energy usage of individual appliances and devices. However, smart plugs may not be suitable for all applications, as they are limited to monitoring plug-in devices. Alternative solutions such as time-of-day pricing, flat-rate charges, and parking meter systems can also be considered. Time-of-day pricing encourages tenants to reduce their energy consumption during peak hours, while flat-rate charges provide a predictable and easy-to-manage billing option. Parking meter systems ensure that tenants only pay for the time they use the garage. When evaluating these options, it is important to consider the specific needs and preferences of the tenants. Some tenants may prefer the accuracy of individual meters, while others may be more concerned about the cost of installation. The chosen method should be fair, convenient, and easy to understand for all tenants. In addition to the technical aspects of submetering, it is also important to consider the legal and regulatory requirements that may apply. Some states and municipalities have specific laws and regulations governing the submetering of electricity in multi-unit buildings. These regulations may address issues such as billing practices, tenant rights, and the installation and maintenance of submetering equipment. Before implementing a submetering system, it is essential to consult with an attorney or legal expert to ensure compliance with all applicable laws and regulations. This will help avoid potential legal disputes and ensure that the submetering system is operated in a fair and transparent manner. Moreover, it is advisable to establish clear and comprehensive written agreements with the tenants outlining the terms and conditions of the submetering system. These agreements should address issues such as billing methods, payment procedures, dispute resolution mechanisms, and the responsibilities of both the landlord and the tenants. Having a well-defined agreement in place can help prevent misunderstandings and ensure that the submetering system operates smoothly and equitably. Furthermore, consider the potential impact of the submetering system on the building's overall energy efficiency. By providing tenants with detailed information on their energy consumption, submetering can encourage them to adopt energy-saving practices and reduce their overall energy usage. This can lead to significant cost savings for both the tenants and the building owner. To maximize the energy efficiency benefits of submetering, consider implementing additional energy conservation measures, such as installing energy-efficient lighting and appliances, improving insulation, and optimizing heating and cooling systems. These measures can further reduce energy consumption and enhance the overall sustainability of the building. When selecting submetering equipment, it is essential to choose products that are reliable, accurate, and easy to maintain. Look for equipment that is certified by reputable testing laboratories, such as Underwriters Laboratories or UL, and that meets industry standards for accuracy and performance. Consider the long-term costs of ownership, including maintenance, repair, and replacement costs. It is also important to choose equipment that is compatible with the building's existing electrical system. If the building has a smart grid or other advanced energy management system, ensure that the submetering equipment can be integrated seamlessly. Moreover, the submetering equipment should be installed by qualified and experienced electricians who are familiar with the NEC and other applicable codes. Proper installation is essential for ensuring the accuracy, reliability, and safety of the submetering system. After the submetering system is installed, it is important to monitor its performance regularly and address any issues promptly. This includes verifying the accuracy of the meters, checking for any signs of damage or malfunction, and ensuring that the billing system is functioning correctly. Regular maintenance and calibration of the submetering equipment are also essential for maintaining its accuracy and reliability. It is also important to provide tenants with clear and understandable information on their energy consumption. This can be done through monthly billing statements, online portals, or mobile apps. The information should include details on the tenant's energy usage, the cost of that usage, and tips for reducing energy consumption. Providing tenants with this information can empower them to make informed decisions about their energy usage and reduce their overall energy costs. In addition to the technical aspects of submetering, it is also important to consider the ethical and social implications. Submetering can have a significant impact on tenants, particularly those with low incomes. It is important to ensure that the submetering system is implemented in a fair and transparent manner and that tenants are not unfairly burdened with high energy costs. Consider offering energy assistance programs or subsidies to help low-income tenants manage their energy bills. It is also important to educate tenants on energy conservation practices and provide them with the resources they need to reduce their energy consumption. By addressing the ethical and social implications of submetering, it is possible to create a system that benefits both the tenants and the building owner. In summary, implementing a submetering system for a 4-unit apartment building converted to condominiums with a detached garage requires careful consideration of various factors, including cost, accuracy, convenience, fairness, legal and regulatory requirements, energy efficiency, and ethical and social implications. By thoroughly evaluating these factors and selecting a submetering system that meets the specific needs of the building and its tenants, it is possible to create a system that is both effective and equitable.